Hello friends, this is Jim with Science Talk. I have a story here about ozone. Ozone loss may have caused mass extinctions. The loss of ozone may have caused the extinction many millions of years ago of most life on Earth, scientists hypothesize. Scientists from California have found a new possible mechanism to account for extinction and to explain other large die-offs on a planetary scale. 7 out of 10 land animals died at the end of the Permian age, which was about 252 million years ago. So did 95% of marine species. In fact, at the end of the Permian is one of probably the most massive of the mass extinction events, and nearly all life on this planet, at least definitely multicellular, or at least eukaryotic life forms, nearly they all perished. So what is the possible mechanism for this mass extinction? Usually in the past, for example, at the Cretaceous-Tertiary boundary, we have the evidence of a big rock tumbling out of the sky, impacted off the Yucatan Peninsula, off in the Gulf of Mexico, and thereby sealed the end for most dinosaurs. Not all dinosaurs went extinct. And there's been other evidence of impact sites that could explain, that tend to coincide with other mass extinction events. Well, the Permian, because first of all, it's 252 million years ago, so if there were any impact sites, craters, and so on, probably have mostly been erased with all the passage of time. But what the scientists are now hypothesizing is that the mass extinctions at the end of the Permian might be the result of the destruction of atmospheric ozone. Ozone in the atmosphere is a protective layer found in the stratosphere that eliminates or reduces the amount of harmful ultraviolet light that reaches the surface, UV light. Jeffrey Benka of the University of California, Berkeley and colleagues report in the journal Scientific Advances that they irradiated a series of dwarf pines with doses of ultraviolet B radiation up to 13 times stronger than any on Earth today. They used 60 pines of the species Pinus mugo, irradiated them for 56 days, and then spent 3 years examining 57,000 pollen grains produced over that period. UVB wavelengths typically are associated with mutations in DNA. DNA, of course, contains our genetic material and is the basis for inheritance. The dose chosen was the one to which organisms might have been exposed at the close of the Permian period, an episode characterized by immense volcanic eruptions that would have damaged the upper atmosphere. So there's a mechanism for why atmospheric ozone could have been destroyed or compromised. The researchers found after 2 months exposure, the trees survived but at a cost. They became sterile. Their cones shriveled within days of emerging. Once restored to present-day open-air conditions, the pines all recovered. But if this is back in the Permian with the conditions that they think were happening, chances are the cones would not have recovered. Now, of course, without plants form the basis for ecosystems. Plants are the producers, they're the autotrophs. You then have the primary consumers, the herbivores, that will ingest the plant material. The herbivores are then provide food for secondary consumers, the basic primary carnivores, and so forth. So if plants are now not reproducing, you can see what happens, that the plants would eventually die off and the whole ecosystem would come collapsing down. So why is this important? Well, you might recall that recently there was the discovery of the quote-unquote ozone hole over the Antarctica, and that was then determined to be the result of chlorofluorocarbons, CFCs, being released into the atmosphere. Chlorofluorocarbons at the time was typically found in refrigerants, in the coolant of refrigerators and so forth. They have since, CFCs have been banned and no longer in use, and the ozone hole is improving, it's recovering, and it's becoming smaller and smaller. Although it's interesting to note that a smaller ozone hole was discovered over the northern hemisphere at high latitudes. I think it was over the Canadian Shield, if I recall the research correctly. So, like I've spoken about in previous videos, oftentimes by studying what took place in the past can give us clues to what could happen in the future or what could be happening now in current condition. If we understand mechanisms in the past, that might help explain current situations, as well as what the possible outcome of those situations could be, as well as then be a predictor for possible future scenarios. So the slowly unfolding extinction on land over maybe tens or hundreds of thousands of years may have been caused by reproductive troubles at the base of the food chain. If the plants are sterile, that's what's being talked about here. However, ozone may not be the only suspect in the Permian mass extinction mechanism. Other researchers have already suggested that high atmospheric carbon dioxide levels by massive volcanic output. Also, if you have a high level of CO2 in the atmosphere, you have CO2 mixing with the water at the air-water interface, like oceans, lakes, making the waters more acidic. Water plus CO2 equals carbonic acid. Carbonic acid is a weak acid, but still it is still an acid. The pH will still be lowered, and organisms that have shells or tests as part of their structure will find, and especially if the shells are made of calcium carbonate, like corals and a lot of mollusks and so forth, snails, that kind of thing, the shells dissolve. That's obviously not good for the organism. So, biologists may never be able to exactly pinpoint the cause of the Permian mass extinction, but they have a couple of working hypotheses, and like everything else, if you look at what's going on in today's planet, we're putting a lot of CO2 into the atmosphere. There is already notice that the oceans are becoming more acidic in the upper layers. As I said before, things that happened in the past can help explain what's going on at present or the coming events in the future. So I wanted to share that story with you. What may seem trivial, oh, who cares what happened 225 million years ago? Well, as we discussed quite a few times here, the past can help explain the present and the future. Thank you for your time. If you like the video, please share the video. Please inform others of my channel and of the work I do here. Subscribe, click the bell, post on social media. Become a patron at patreon.com/Science Talk with Jim Massa. Thank you for your time.